Hello everybody, Stuart here again, and today we are looking at plastics. What are plastics and what are they made out of and how are they made? These are some of the questions that we will be answering in today's lesson. Basically, my degree of industrial design is very focused on plastics, and I know a lot about plastics, and I want to inform everyone else about the truth about plastics and that plastic is not a material. The word plastic is actually a description. It means moldable or able to change shape. So what is plastic made of then? What is plastic? Well, actually plastics are a polymer, which is a chemical structure of long chains of molecules joined together in specific ways. And there's a whole division of science dedicated to this, and it is called polymer science. And this is the field of studying and creating different arrangements of these molecules to develop materials with unique and useful properties. And one of the main focuses of polymer science is on synthetic polymers. And this is the crazy thing about polymers, is that it isn't only limited to plastics as we know them. There are many natural and biological structures consisting of polymers. And some examples of that are things like wood and cotton and paper, which all have a cellulose base. Cellulose is a natural polymer, and DNA is actually a polymer itself, a biopolymer. But the closest natural thing that we have to what we typically view as plastic is rubber, which comes naturally from the sap of certain trees. And it's what we've been using for centuries to change the properties of other materials and to also use those in creating materials that have not natural properties. And that's where the whole idea of synthetic polymers or synthetic plastics come through. So this lesson is focusing on synthetic polymers, and specifically polymers that we generally call plastic. And we make pretty much everything out of plastic these days, and so we want to know what it is that they actually are, what type of material plastic actually is, and the technology around making it into useful stuff. So I hope that this is going to be an exciting adventure for you, and I'm really excited because just now I'm going to go into a factory that is molding plastic materials into products. And so we'll have a look at the whole process of turning plastics into things. Let's get stuck in. Right, so before we go in depth on how plastics are formed, because remember, plastic means the ability to change shape or moldable, and so a lot of the technology that we use to turn plastics into products involves molding it. And there's a whole bunch of different technologies for molding, and we'll look at two of them in the factory later on. But for now, we're going to look at the two main types of plastics. So I said before that plastic is not actually a material, it's a description of a material, but here we've got the description very much linked to the moldableness of the plastic itself. So the first type of plastic that we've got is what is called a thermoplastic. And it gets soft and moldable when they are heated up. So that's why it's called thermo, so heat, plastic. And the majority of plastics that we use and that things are made up of around us are made out of thermoplastics. So typical Lego bricks are made up of a thermoplastic called acrylonitrile butadiene styrene, or the truncated version of that is ABS. And so that's why we call it ABS and not acrylonitrile butadiene styrene. And the majority of Lego components are made out of that type of polymer, and ABS is a thermoplastic. So if we heat these components up and we get them hot enough, they'll start melting and going soft, and we can remold them. But then we've got thermosetting plastics. And thermosetting plastics are used in a lot more hardy applications a lot of the time because they have a molecular structure that cross-links when the plastic is molded. And that cross-linking of the molecular structure means that once it's molded, it's permanently locked into that shape or into that state. And so this sort of electronic jump wires that we've got, these little bits of the connections on the end, they're made out of a thermosetting plastic. And the reason that is used there is because if something like this gets very hot, the casing of this is not going to start melting. But the problem with thermosetting plastics is that we can't ever recycle them, because once it's in this shape, it can never be heated up and melted down and remolded like thermosetting plastics can. And this is a big problem because car tires are made out of a thermosetting rubber. And that's why car tires are not recyclable. And I don't know about you, but my car uses tires much faster than I'd like them to. It's probably not a problem that you have come across yet, but in the future, you'll understand that when you buy tires, it's a grudge buy. I don't want to have to buy tires because I don't ever really see the direct benefit of it, and they're not recyclable. So we can't melt them down and make them into new tires. It's thermosetting. Okay, so those are the two different types of plastics, the two main categories. We've got thermosetting plastics and we've got thermoplastics. Another cool thing, but a bit of a problem from a recycling perspective, is that carbon fiber, we've got those carbon fibers that are woven into a fabric, and then we impregnate that fabric with a thermosetting resin. It's normally an epoxy resin, and that is not recyclable because it cross-links, it bonds permanently, and that's one of the reasons why it's so strong, but it's not recyclable and it can't be remolded. It can't be heated up and melted down. And again, that's got benefits and it's got negative aspects to it at the same time. And a lot of the time, technology is really looking at how do we make use of the benefits and balance them out against the negatives of the materials that we choose. Okay, so we've looked at the two main types of plastics. We've got thermoplastics and thermosetting plastics. Some of the common plastics that we use have got typically very long and complicated names, like acrylonitrile butadiene styrene. Another one that you probably have seen before if you look on a lot of these. So this is a skin product bottle. It's a really beautiful plastic. It's got a lovely translucency to it. It's super shiny. It's just a very, very good looking kind of plastic. What is this plastic made out of? Well, on the recycling code, it says that it's 1, that's the symbol for it, and it's got PET. And PET stands for polyethylene terephthalate. And this is an incredibly versatile and useful polymer. And so a lot of products that we'll see, if you start to look carefully, are made out of PET. One of the other really, really amazing things about a lot of different plastics is that we can treat them with surface treatments. So this silver around here is put on with such an incredible technology. We'll have to do a video on it at some point. And this is metal that's been fused to the plastic by a process called vacuum metallizing. And it's just so crazy. They take a metal and they vaporize the metal, and then they attract it to deposit itself on the surface of the plastic. And then you get this super shiny metal surface, but a plastic material. And that's just wildly cool. Technology and science and all of these things come together when we start looking at products and the material science around how it works, and it's just too cool. Okay, so this is polyethylene terephthalate, or PET. Lego is made out of acrylonitrile, butadiene, styrene, and there's a whole class of materials under the name of styrenes. And so that's a cool plastic group or polymer group to start looking at. And then we've got other types of plastic. And so if you have a look at your toothbrush, now a toothbrush is a pretty incredible piece of technology. These bristles are generally made out of a plastic known as nylon. And nylon is a polymer which has unbelievably good properties or mechanical properties. So it's extremely tough, it's extremely hard wearing, it's very good with shock. So if something hits it hard, it doesn't deform, it doesn't break, it stretches, but it doesn't stretch too far, it returns to its shape. It's a term they use of modulus of elasticity. And it's got a very high or relatively high melting temperature, and it is extremely resistant to breaking down and degrading over time. And that's again one of the biggest problems, because fishing line and fishing nets are typically made out of nylon, and they take hundreds of years to break down, and they've got very good UV stabilization a lot of the time, because the sun is what generally damages plastics and breaks them down. So if it doesn't easily get damaged by the sun, it's not going to break down over a long period of time. And I think that fishing line slowly starts to degrade, and I think it degrades over time over about 400 years. So if this ends up in the sea or something, these bristles will probably still be in this shape in 400 years time, or slowly start to break down over that period. But there's a lot of other materials that are actually in this toothbrush, because we've got the bristles, and the bristles are made out of a different material to the body of the toothbrush, which is also made out of a different material to the center bit that sort of is more like soft and rubbery. And so these are all thermoplastics, so they get soft when they're heated up, because for a typical application of a toothbrush, it doesn't have to get very hot, right? Our mouths are not incredibly high temperature environments, and so these can be made out of thermoplastics without having to worry about it getting soft or getting damaged because it gets too hot. But the molding, or the over molding of this is a really cool technology that we'll unpack a little bit later on. But here we have and I'm not entirely sure what this material actually is, but it's probably an ABS or a PET, and this material on the inside, this white material, is what we know as a thermoplastic elastomer. And a thermoplastic elastomer means that it's a rubbery material, but it can be molded into these shapes, because it's a thermoplastic. So it can be heated up and it's molded over this. So they first mold the blue part of the plastic, and then after that they mold the white part of the plastic into it. And the amazing thing is that when they mold the blue part, they have the bristles in place already, and they mold it with the bristles already in place. So that's how the bristles are stuck in, and they don't come out easily. So a toothbrush is an incredible piece of engineering and technology in terms of being able to produce it. Right, so we've got this Lego tire is actually made out of a thermoplastic elastomer. It's not made out of the same tire material, the rubber that I was talking about earlier on. It's just that I can't fit an entire tire under this camera. But did you know that Lego is actually the largest tire manufacturer in the world, because they make more tires than anyone else, even though they're small. Right, so we've got other things like rubbery materials. I am not entirely sure what material this rubber is actually made out of, because I'm not a polymer scientist, but it's either a rubber-based compound or it's a thermoplastic elastomer. But I'd stand to be corrected on what that is. Now, we've got all of these things. We've got a lot of these wires and cables, these flexible plastics are made out of a polyvinyl chloride polymer, and you can even hear that polymer coming through in the name, polyvinyl chloride. And we know this, you've probably heard of this before, it's made out of PVC. And so a lot of the time, the names that we know of plastics, if we know that there's different types of plastics, we know it by its abbreviation, because the full name is a very long and complicated one. We've got other materials like acrylics. As I said before, we've got styrenes. Let's see if we can see what material this mouse is made out of. If we pull this section off over here, you can see on the inside it says ABS, and so that is acrylonitrile butadiene styrene. So a lot of technology products, a lot of tech is molded, the housings of it are molded out of ABS, and it's a really, really versatile and useful plastic in there as well. Right, then we move over to molding plastics. How are they turned into this shape? And this is where we can start to introduce 3 different molding processes based on the bits and pieces that we've got here. Now, the first and the most basic way of molding plastics is to extrude it. And so just like spaghetti is mixed into like a dough and then it's extruded through a bunch of tiny little holes, if we get a whole bunch of plastic and we push it through a profile, then it will start to take that shape. So a lot of things like this PVC tube is an extruded product. Okay, so that's known as plastic extrusion. And there's a whole bunch of different cool things like this. This is what we call heat shrink, and we use it in electronics and all sort of electricians use it a lot. And there's different thicknesses. This is an extruded plastic, but when you heat it up, it shrinks because it's called heat shrink. And that's really, really cool, because then we can use this if we wrap 2 wires together and we solder them together, but the insulation, like this PVC insulation on these wires, has been stripped away. We can use this to slide it over that wire and then heat it up, and then it shrinks and protects the wire that we've joined from being able to short circuit. So these are examples of extruded plastics. Now, if you look at this is super, super cool, because this is what we call a co-extruded material, because all of these are molded in one piece. You can see that they don't mold them and then stick them together. They are molded all as one, but they're a whole bunch of different colors. How do we get those different colors? Now, this is where it just gets incredible, is that there's a whole bunch of different colors in the machine, and they all fed in separately, and those colors only mix just at the point where they are coming through each little hole, and they melt together as it comes through the extrusion machine. So this is extruded as a solid strip like this coming out, and then afterwards they separate these top sections and add the little connectors onto it afterwards. So this is a co-extruded component, which is really, really amazing, and it's pretty cool with all the different colors. Okay, so that's going from the most basic extrusion to slightly more complicated co-extrusion. The next most common, and probably the most common production method for manufacturing method for electron or plastic components is injection molding. And so something like this is injection molded, and I'm not sure if it's injection molded in 2 parts. It might be. And then we've got things like the Lego block. And the Lego block is a really, really great example of something that has been at least injection molded, okay? Because we've got a mold on this side and we've got a mold on this side, and then we've got a little point where the plastic is forced in. So they have a cavity, and this is something that we'll go and have a look at, because this is the process that we'll be looking at in the factory just now. But a injection molded component is where you have the negative shape of this part, and it's two different metal blocks that close together with the metal shape in it, and then they inject plastic, melted thermoplastic, into that space, and then they push it in very, very high pressures. So it's normally a few tons or a few tens of tons of pressure to be able to force this plastic into filling every cavity of that mold and getting a really sort of sharp edges, and making sure that the plastic's filled that mold and getting all the detail. And from there it opens up and it pushes that molded part out when it's cooled down enough to be solid again, when the plastic has frozen. So that is the process of injection molding. The next one that we're going to look at is basically a combination of extrusion and injection molding, and that is known as extrusion blow molding. And this is a technology that is used incredibly broadly across a whole bunch of products, and a lot of these like toiletry products and cleaning products and things that we use as storage containers, particularly for liquids, are extrusion blow molded. And so if we take this off and this is still full, this part is something that's injection molded. Okay, so the lid is injection molded, but the top, or at least the body of it, is extrusion blow molded. And you can see over there, it tells us what material it's made out of, and that says HDPE. And so that is high density polyethylene. That's the name of this material. And polyethylene, or the ethylenes group, are an incredibly broad range of plastics as well. It's a whole group of plastics. So we've got HDPE, we've got LLDPE, which is linear low density polyethylene, and a lot of those or a lot of plastic bags and that sort of thing are made out of that. A lot of sheet materials are made out of linear low density polyethylene. But we're talking about the manufacturing process. So as I said, this is made from extrusion blow molding. So this starts its life as an extrusion, just like this, but it's much bigger, much wider. And as the material extrudes it down, it comes into where a mold clamps the extrusion from the top and the bottom, and you can see where the mold is clamped it. So you can see that line running along the top there, and the line running along that side, and you can also see there's a line running all the way down the side here, all the way down this side, through to the bottom. Let me stick the lid on first, because I don't want the shampoo to go everywhere. There you can see the line very clearly. So that's the area what they call as pinch offs. And so what happens is the mold will, the plastic gets extruded straight down, the mold clamps on either end, and then it blows air into the section where it's molded, and it forces the plastic, while it's still soft, out into the edges of that mold. And so we'll show you an example of an extrusion blow molded component in the factory when we go through there now. So those are three of the manufacturing processes that we're going to have a look at as well. So we've got extrusion and co-extrusion, we've got injection molding, and then a combination of those two, extrusion blow molding, where we extrude it, instead of injecting it, we extrude it, then we clamp the mold on either side and we blow air into it to fill that mold cavity and to take the form of it, and then it pinches it off the plastic on either end and opens up, and we've got our complete container ready to be labeled and to be filled with whatever product is going to be stuck in there. Okay, so as an overview, we have got two main types of plastic. We've got thermoplastics and we have thermosetting plastics. Thermoplastics get soft when they are heated up, and we can use that to mold them. Thermosetting plastics need to be molded, well, can only be molded once, And once it's molded into that shape, it stays in that shape permanently unless it gets broken. Then we also have the concept that plastic is not a material itself, it's the description of a group of materials, and those materials are largely known or known better as polymers. And all of these polymers are specific materials with different names like acrylonitrile butadiene styrene, ABS, we've got PET, or polyethylene terephthalate, and we've got high density polyethylene, HDPE, and all of them have their own recycling codes because all of these materials are recyclable. Then the unfortunate thing about thermosetting plastics is that they are not recyclable. Right, so I think that is a good enough overview of the theory around plastics that we're going to look at now. And from here, we're going to move into the factory where we'll have a look at some of these plastic components being made. I hope that you found that interesting and exciting. I'll catch you in the factory.